We're surrounded by optimization problems. In finance, for example, you might want to maximize the return of an investment portfolio while minimizing its risk. In engineering, you might want to design a vehicle that minimizes drag, maximizes crashworthiness, but also minimizes cost. These types of problems are called multi-objective optimization problems, or MOO for short, and they're a particular challenge for today's computers. Let's talk today about a new paper in Nature magazine where IBM is using quantum computers to try and solve these problems better. The challenge with MOO is that there is no single optimal solution. Take our finance example. You might have a low-risk portfolio, but it also comes with low returns, whereas a high-return portfolio would come with high risk. In between, there are many portfolios that trade off that risk versus return. We can plot these optimal portfolios on something called a Pareto front, which I think is a great name because it reminds me of a cold front on a weather map. The Pareto front can aid the analysis to find just the best trade-off between here risk and return. But finding this optimal Pareto front can be a challenge, particularly if we get into problems with 3 or 4 objectives. The search space just explodes. But quantum computers are particularly well suited towards searching large spaces. The IBM researchers used an algorithm called QAOA, or Quantum Approximate Optimization Algorithm, and they added a novel approach called parameter transfer, where they trained the parameters for QAOA on a smaller problem on a classical computer, and then transferred those parameters to the larger problem on the quantum computer. And the initial results are pretty promising, particularly for those problems with 3 or 4 objectives. Secondly, the researchers were able to forecast how this approach would work on quantum computers as they become less noisy in the future. So if IBM continues to march along its quantum computing roadmap, we could see quantum advantage for these types of optimization problems. It's an exciting time in quantum computing. What sort of optimization problems would you want a quantum computer to solve? Let me know in the comments below.